All right, today we're doing 7-7, which is line of best fit. So the purpose of today's lesson is to find an equation of a line of best fit for a given set of data. Can everybody say line of best fit?
Line of best fit.
Okay, a line of best fit is basically us taking real data and we're going to make an equation, a mathematical equation that will describe the relationship between two quantities of any kind, of within that parameter. So here we go. I've put the graphing calculators out. Today we're not really going to do this with graphing calculators. We will do this eventually with graphing calculators. I'll show you how to do it on the graphing calculators. I'll show you how to do it on the free graphing calculator called Desmos. And then, both are great. Desmos is great while you're doing your homework, but you can't take it with you to the SAT. That's why I teach you also on the TI-84. It's pretty standard calculator that you will use in pre-calculus. All right, so a scientist comes to his group and he's asking the question, does the weight of a brain have anything to do with how long something lives? And so they look at this and they look at averages of different. Now, before we even do this, I want to ask you, within this situation, what depends on what? Does brain weight depend on life, on your lifespan, or does your lifespan depend on your brain weight? What do you think? Yes.
Your lifespan depends on your brain weight?
So the lifespan is the depender. You guys with me? Mm-hmm. So whenever you look at this, you have to ask yourself, what is the depender and what is independent? I just look for what is the depender. And if lifespan is the depender, that goes on the y-axis. The depender is always the y. That means x is the independent, and so that would be brain weight, and the lifespan would be the depender, and that would be the y. So whenever you make a graph, you have to label each side, not just with numbers, but with a title. Otherwise, your graph means nothing if you're just plotting data and you don't give the x-axis an actual name and the y-axis an actual name. Does that make sense? Now, if you're given data like this, how do you make the graph? You always ask yourself, what is the depender? So when you ask yourself what is the depender, you place that label on the y-axis. Does that make sense? Now, another thing I want you to notice is look at the scale, okay? The scale of brain weight, we have to make sure that it goes from 4/10 all the way to 440. And the scale of lifespan is going from 3 2/10 all the way to 50. So I don't need this to be in the hundreds. Otherwise, we're barely going to see anything. All the data, if I made this 100, all of my points would be somewhere down here. Does that make sense? So the scale doesn't have to match. Is everybody clear on that? Mm-hmm. So I just have to make sure on the x-axis I'm going from almost 0 to 500, which it does. And on the y-axis I'm going from 0 to like 50 or higher. I would go higher, slightly higher. So then we're going to plot the points. Notice I'm going 0.4, I barely go up, right? I barely go across because it's at 0. So 0.4 is almost on the line, and then I go up to like 3.2, right? You guys with me? And then the next one, I'm going to do 50 across. I'm going to show you this. I can't show it really in here, but I'll show it here. I'm going 50 across, and then we're going about 9 up, right? And I'm plotting the point. And we go 157 over, a little more, and then 22 up. And then we're going to go 175 across, and then we're going to 20. And then we're going to go 180, and then all the way up to 27. And I'm going to just keep plotting these points. Are they exact?
No.
No. this is what we call a scatter plot because the data is scattered. Okay, this is a scatter plot. The data is scattered. Now, we are trying to find our goal here, the purpose of this, is to find an equation that describes any brain weight to any lifespan. Of course, there will be outliers. The jellyfish. A kid told me in the last class that there's a form of jellyfish that that's been known to live for thousands of years. Okay, so there are outliers, but this is just to try and create the general formula. All right, so when you get a graph like this, we talk about it in a certain way. We use certain language. The first language that we use is we talk about the trend and what it looks like. What shape is this kind of making? A line. We say it has a linear trend and it's going from low to high like the money, so it's increasing. The trend is increasing. Okay? If it started high and it went low, we'd say the trend is decreasing. We say it's a linear trend. You guys with me? Okay, everybody say trend is increasing. Say it's a linear trend. Good. Now, when we find our line of best fit, what we're going to do is these points will act like a magnet attracting a line. Hold on, and I'm going to show you. Hold on. Okay. Would this be the best line? No. To attract all the magnets? Okay, would this be the best line? No. Would this be the best line? It could get closer. We kind of want to choose the line. Is this? No. Yes. Okay. Where you're having equal number of points above and below. Kind of in the middle of the line. That's where you're going to draw your line. Okay. Once you do that, we want to pick 2 points. Okay, so here's the steps. I want you to write this down. Number 1, we plot the points. Number 2, we draw a line of best fit. Number 3, we take 2 points off the line. Okay? And then we're going to, okay, let's look up here before you're writing. And then I'm going to let you write. Everybody look. We're going to take 2 points, and what can we do with 2 points?
Find the slope.
Find the slope, right. Now, we want to pick our points that are sufficiently spread apart. If I were to take, like, this point, let me go a different color. If I were to take this point and maybe this point, look at the angle of that line, right? It's going to kind of like, sorry, I think it'd be better if I just do line right here. Look at the angle of that. You see how it really kind of changes it quite a bit. Does that make sense? Well, yeah, I can't really draw a line, so with this. So you're going to pick 2 points, and you want them to be sufficiently spread apart. Okay? Now, pause the recording. You can write the direction. All right, so now that we have the 2 points that we've chosen that are sufficiently spread apart, we have the ability to find what? Slope. So I'm going to use my slope formula, and then we're going to substitute in. I'll do 50 minus 10, right? I do 50 minus 10. Oops, I didn't mean to do that. I'm doing 50 minus 10 goes in the numerator, and 450 minus 50 goes in the denominator. And what do we get? 40 over, right? We're getting 40 over 400. We can reduce it right away. I'm doing this. 4 goes into 4 once. It goes into this 10 times. How would I write that as a decimal? 1/10. 0 and 1/10, right. 0 and 1/10. We like to reduce it, and generally line of best fit, we use decimals because we're in the calculator so much. We can do fractions in the calculator, but it's easier to just do, then you have to go to, I don't know, it's just more work. So I found this. Now, this is the point where you have a choice tonight, and I suggest you do half the problems one way and the other half the other way. Your choice is, am I going to use y equals mx plus b and solve for b, or am I going to use point slope? Because now you have a point and you have a slope, right? We have a point and we have a slope. So it's your choice. So when I do y equals mx plus b, I'm going to show you both ways today. This is using solving for b. So I'm substituting in the y is 10 equals 0.1 times my x is 50 plus b. So I get 10 equals 5 plus b, subtract 5, right? Is that right?
Yeah.
And 5 equals b. Okay, so now we've got, we have our m, we have our b. What is my m?
0.1.
Okay, 0 and 1/10. I want to hear you guys reading those decimals correctly. Y equals what?
0 and 1/10.
M plus 5. And you know what? Actually,
Isn't it x? Yeah, it's 0 and 1/10 x.
oh yes, sorry, x. Sorry. X plus b. Look what I did. Okay, plus 5. You guys with me? What happened there? Okay, 0 and 1/10 x plus 5. And then, oh, I know what happened. I was erasing. When we're doing this, because we're taking real data and we're estimating, that's the point that we switch this to the about sign. Okay? That's when we switch it to the about sign. As soon as I'm making my line of best fit, we're using the about sign. Okay, are there any questions? Now, could I have done point slope at this point? Yes. You still always have to find the slope, but here you have the choice. Okay? I'd split it up so you get good at both. All right. So I asked you, the question is, which scatter plot below shows a linear trend? Does A? No. Does B?
No.
Does C?
Yes.
Okay. And does it have a positive correlation or a negative correlation? Everybody say negative correlation. It's one of my words on the board there. Does it have a positive correlation? We said positive correlation, negative correlation. Look at D. Does it have a linear trend?
No.
Does it show a linear trend? What about E?
Yes.
Okay, and if it does have a linear trend, is it a positive or a negative correlation?
Positive correlation.
Everybody say it.
Positive correlation.
Yes.
And for you, do you always have to start at the bottom or wherever the class?
We always read a graph from left to right. So if it starts high, and okay, imagine this is money. As I go further that way, does it get higher or lower?
Lower.
So that's negative correlation. Here it starts low and it goes what? Higher, so that's a positive correlation. When it's increasing, it's a positive correlation. When it's decreasing, we always read from left to right like a book. Okay, and F, whoops, didn't mean to do that. And F, where are we at? What is it? A linear trend? Yes. It's neither, kind of, right? It's neither. Not sure what's happening. Okay. It's stuck. Okay. Hold on. Let's see if right here at all. Here we go. All right, so now, finding our line of best fit, here's some rules, okay? When you find your line of best fit, we're going to see this little outlier, the jellyfish with the brain that could live for thousands of years. We're going to ignore the outliers. Those are the purple Jolly Rancher pickers. If I were to do statistics on Jolly Rancher lovers, purple would be the outlier. So we are ignoring the outliers, okay? When we choose our line, when we choose our points, it doesn't have to go through those points. I could just pick a point on the line. Equal number of points above and below the line. Remember, it doesn't go here. It doesn't go here. Is everybody understanding? Equal number of points above and below. The points act like a magnet. Remember on the last one we chose 450 and 50? That wasn't an actual data piece. It was right next to one. So you can choose points on the line, or you can choose points right on the line, or actual data points maybe right next to it. Do you understand? It's not exact. You do want to pick two that are far apart. All right, I'm going to pause the recording. You can finish writing the rules for picking your line of best fit.